Audio Jungle.
Hello, Marcus here. I want to tell you about two things that really excite me: end-to-end and industrial automation. And we've built a lab to investigate those two dimensions. We call it the Future X Lab. But to tell you more about that lab, I want to introduce you to my personal assistant. Hello, everyone. Welcome to an exclusive preview of the Future X Lab. This lab is not a demo lab or like any other lab. It's a complete build-out of the Future X network end-to-end across all 9 domains. We have integrated the entire leading-edge Nokia portfolio, including an array of innovations from Bell Labs. More from him later. Now we're off to the first part of the experience. Welcome to the Service and Slice Operations Center of the Future X Network Lab. This is essentially the bridge of the Starship Enterprise, meaning the place where we configure and control all the options and then make them so. So Chris, we've got a very sophisticated network diagram. It seems to have a lot of domains. I'm familiar with most of them, but tell us a little bit more about what's going on here.
Absolutely. So the tool here allows us to configure the end-to-end network, and it does represent all 9 domains of the Future X network architecture, from the devices to the massive scale access networks, fixed and wireless, the converged edge cloud connected by a smart network fabric, the IP and optical backbone, and then the virtualized domains within the cloud, from the universal core to the programmable network OS, the analytics and AI layer, the digital value platforms, and of course, security.
Okay, Chris, over here we have a second screen. At the top seems to be economics and at the bottom performance. Can you tell us a little bit more about what's going on here?
Absolutely. So as we configure the network, we get to see the impact on the total cost of ownership and on the performance metrics. At the top, we are looking at total cost of ownership of the end-to-end use case for the target geography. And at the bottom, we are looking at the performance of the end-to-end use case along these 6 critical parameters of latency, bandwidth, scalability, reliability, and security.
That's great, Chris. And so what you're saying is every time we change something in the network, this all gets recomputed so we understand the consequences of the changes we're making.
Absolutely.
Great. So Chris, looks like a very cool tool. Unfortunately, we don't have the time to explore all the domains and all the capabilities. But given that 2019 is the beginning of the era of 5G, why don't we dive in on massive scale access? Show us what we can do.
Absolutely. So you can see that the 4G icons over there are highlighted, and we can actually go in and change the access network from 4G to a variety of different access networks, from Wi-Fi to fixed wireless access, and of course to 5G. And if we select 5G, there are options we can choose beyond that, including using alternate spectrum like 28 gigahertz, massive MIMO technology, or ultra-reliable low-latency communication features.
And I see that as you were doing that, the performance criteria were being exceeded. In fact, we've done very well on latency, bandwidth, scalability, and the economics look very attractive. They've come down relative to the 4G economics, so that's all good. I noticed a couple of parameters there that we haven't quite achieved the goal on reliability and security. Can we get us there?
Absolutely. So of course we can go into the security domain and we can turn on features there as well. We can turn on things like massive scale IoT security, distributed edge DDoS protection, and end-to-end threat analytics. And in order to help reliability, we can go into the programmable network OS and turn on end-to-end orchestration.
And lo and behold, you were right. We met the target performance criteria at very attractive economics. So thanks, Chris, for leading us on this whirlwind tour of the Starship Enterprise. I mean, the SOC. And we're off. Welcome to the Future X Emulator. This is an immersive room we've built that allows us to explore the new industrial use cases by emulating them. And we emulate them under network control, so all the network slices we've set up are active in this environment, and we get to explore how the 5G network of the future, the Future X network, will actually make a massive difference in terms of enabling those use cases. So Ken, tell me what's going on here.
So Marcus, this is the holodeck of the Future X Lab. Here we can, in the virtual space, we can represent any physical environment that we desire. Here we've represented a factory environment where we are manufacturing the Nokia home Wi-Fi gateway. We've got robots that are representations of our Bosch partner robots. All of the factory elements are under 5G network control using the slices that we've set up in the Service and Slice Operations Center.
So, Ken, I see we've zoomed in down to the factory floor, and there's well, it looks like a robot. We're going to do something with this guy, I think.
So, Marcus, this is a rescue robot that is under remote control by me over the 5G network. So we've had a malfunction on our factory floor. We have a Bosch unit that we need to take out of service. I need to stand back here and direct that robot to pick up our malfunctioning Bosch unit.
I see you're driving it backwards now and heading towards the elevator where the rescue shop is located.
We're going to bring it up to the rescue shop.
Very nice job.
Off we go.
And in fact, there's a whole other part to this scenario that you'll see if you come to visit us at the FutureX Lab. But Ken, interesting that 5G network performance seemed critical to that interaction. Can we do it over Wi-Fi and LTE? Is the performance the same?
We can do it over Wi-Fi, but it is a world of hurt. Very slow network. You end up crashing the device all over the place. Customers love it because it shows the value of the 5G network.
We showed a factory use case, in fact, only a small part of the use case we've built, but we've got a lot more coming. What do we have coming?
Marcus, we've got cities, we've got mining, we've got transportation, we've got ports. The sky's the limit. This is the FutureX holodeck.
Well, thanks for spending time with us today, Ken, and I look forward to seeing those other use cases. And we're off. And here I am in one of the most critical parts of the FutureX Network Lab. And why? Because here it is. The end-to-end, seamlessly integrated and orchestrated Nokia portfolio. Welcome to domain 1 of the FutureX Network, the massive scale access domain, which is of course one of the most important domains because that means it's the 5G domain. So Peter, tell us what we see here.
So we're showing all solutions for fixed access and for mobile access. And they're all running live, except for this guy. If this were powered on, we would be cooking.
So it's great that we've got it all running live, and amazing actually that we managed to integrate that and orchestrate that as part of a live network. But let's do a little bit of a deeper dive on the technology aspects of 5G. Why don't we pick the latency dimension?
So this is a real user interface. Each time I push a button on this triangle of truth, I actually make a change in the network. As an example, I turn on a more efficient scheduler. And we will see how that improves the latency by 50%. I can move the controller from the cloud to an on-premise cloud. And this gives us an additional improvement of 5 milliseconds. I can turn from 4G radio to ultra-low latency 5G radio. And this really gets us to the millisecond latency we want.
And that 1 millisecond latency is critical for the industrial automation use cases. But rather than seeing it on a screen, couldn't we make use of our friendly Bosch robot here to demonstrate the power of low latency?
So this robot is actually wirelessly connected to ultra-low latency 5G. And this is a safety barrier. And now the robot, when it passes this barrier, will stop within milliseconds. This is to protect people or this glass.
I guess that's the full power of 5G, not possible over LTE or Wi-Fi, Peter.
No, absolutely. This is the power of 5G.
Well, thanks for spending time with us, Peter. Unfortunately, we can't dive into all the other technology domains, which would be fascinating in the massive scale access domain. We're off to the next domain. So we've talked a lot about the dynamic reconfiguration of the access domain and instantiation of core elements in the converged edge cloud, but none of that works end-to-end if you don't have a smart network fabric, which obviously has the IP and the optical domains. We're doing massively interesting terabit things in the IP domain, but what most people don't know is a lot's going on in the optical domain, right, Jesse?
That's right. And we're massively increasing our capacity in the optical domain. We're doing that using 3 dimensions. We've got spectral efficiency, where we increase our capacity using techniques like PCS that we developed in Bell Labs. And we also increase the spectrum on our fiber and use multiple wavelengths. And finally, we're exploring techniques of using multiple fibers, multiple spatial domains in order to increase the capacity further.
Sort of MIMO over fiber in some ways.
That's right.
So spectrum is wavelength, spectral efficiency, using very sophisticated modulation that adapts, and spatial dimensions. And we do all of that today?
We do all of it, that's right.
And running?
Running live on our equipment.
Incredible stuff. Thanks very much, Jesse.
Thank you.
So, Marina, we've just built those 3 network slices from the access domain through the converged edge cloud into work through the smart network fabric, and we took them all the way up to the packet core. We did that live, apparently. It seems incredible to me. Is that real?
Amazingly, this is true. This is the dashboard of the Digital Operations Suite showing the KPIs of the live network slices.
I see the bandwidth of those network slices, and I see 3 colors here on their latency domain. What do the colors mean?
Those colors are the contributions towards the latency from the different domains of the network: the access domain, the smart network fabric, and the packet core.
That's very interesting. So how do we bring all that together?
The way we do that is with the end-to-end orchestration from the Digital Operations Suite, which is in control of all the end-to-end domain controllers.
I see. So each domain has a separate controller, but all brought together under the Digital Operations Suite.
Yes.
Great stuff. Thanks, Marina.
Thank you.
And we're off. We've just seen that end-to-end network automation, which looks very simple at some level, but surely it's complicated.
Yes, absolutely. It's incredibly complicated. And more than just the sophistication of the network, we're collecting an enormous amount of data from the devices, from the network, and the network applications that are utilizing the network. The only way to make sense out of this enormous amount of data is to use AI and machine learning techniques. And we're building tools, we're building applications, and we're building digital value platforms that enable the utilization of that data to optimize and orchestrate the flow of data in the network.
So we focused a lot on network value, and it has a large role to play, but let's go back to that application level, or what we call the DVP. Industrial automation, surveillance is an important application. Do we do something in that space?
Yeah, absolutely. The same intelligence that we've used to orchestrate the network, we can apply up to the applications that are actually using the network. And as you said, surveillance is a very interesting industrial application. Inside this environment, we actually have an enormous number of cameras where we're collecting data from them, we're collecting data from people, from robots, from localization techniques, and we're applying that all to actually understand the flow of people and the movement of devices and information inside of the context of the FutureX Lab.
Very important in industrial application.
Absolutely.
Thanks very much, Chris. And we're off. So before leaving the domain lab of the FutureX Network Lab, it would be remiss not to talk about security, given the massively increased threat surface associated with the IoT devices upon which industrial automation sort of depends. And the network is going to play a new role in the security space, I think. Is that right, Samir?
Oh, absolutely, Marcus. In today's solutions, we use these dedicated network appliances.
In places called scrubbing centers, I think.
Yeah, and these scrubbing centers are very inefficient and costly because you have to practically reroute the network traffic to them. What we are doing in our FutureX network is we are using native capabilities in the network, like streaming telemetry from various sources, and we are using deep packet processing capabilities in our routing fabric. And together, combining these two, we are able to build innovative in-network security solutions.
To solve the problem for the IoT future.
Absolutely, and in the network where the traffic is flowing anyways.
Thanks very much, Samir. And we're off. Welcome to the FutureX City and Factory. Thierry, what is it we've built here?
Yeah, we've built a small-scale, real-world implementation for industrial applications with a factory, a harbor, and a city. And they're all connected on our live 5G FutureX network.
Can you show us how it all works?
Yes, absolutely. We have our automated drone delivery from our harbor to the city. It's controlled by a 5G network with new radio interfaces to achieve ultra-low latency. Our autonomous delivery robot brings the packages to our factory. It's driven over our indoor and outdoor 5G network with a dedicated slice for high-precision robot control. Our mobile factory robots collaborate on this assembly task. They're controlled by this wireless infrastructure with high-precision localization that is just not possible over Wi-Fi networks today.
Great stuff, Thierry. Amazing what can be done over 5G networks. What's next?
Yeah, so we're bringing in startups and industry-leading partners to expand the industrial applications that we have. And in 2019, we expand the logistics, manufacturing, transportation, and enterprise scenarios, and many, many more to come in 2020 and beyond.
Great. Sounds thrilling. Hope everyone joins us soon.
Absolutely.
I hope you have enjoyed this whirlwind tour of the FutureX Lab, and we'll see you here soon in person, escorting your favorite customer for this one-of-a-kind, end-to-end Nokia experience.